Oh, hello there. My name is Jeffery Burgess, and today we'll be doing a sampling problem in the discrete sense of the word. Alright, well here's our question in question. Basically it gives us this system right here with two inputs, and this is our output. And basically it just wants us to determine these four things right here. Now if you're like me when you first saw this, you're thinking, what in the world does this right here mean, this omega? Basically that's just asking for the Fourier transform of this particular function. So to start, we must figure out this part. This one, x of n, this function right here, is simply given as x of n which equals -1. Make sure we put that in parentheses, that's very important, to the n. That's an n, and it looks like an h. Which is also known as e to the j pi n. So now that we have our function pretty much mapped out for us, now we must take the Fourier transform. So let's draw our little fancy f, easily the hardest part about Fourier transforms. And we're just going to take the Fourier transform of our function. Once again, that is an n, not an h. And so basically the Fourier transform of this is going to look something like this. Omega is going to be the summation from -infinity to infinity, delta function of omega minus pi minus 2 pi k. Now you may be wondering, how in the world did I know the Fourier transform was this? Well, the answer to that question is there's this beautiful thing called Google. And Google is what told me that was the Fourier transform of that. And I may have seen the solution to this problem, but that is beside the point. So now that we have our x of n, let's figure out our piece of n. Here our piece of n is seen before you. So now let's figure out what that is in terms of a function. Let's get that written down. Well, from this we can obviously tell that it's going to be 1 plus, this is the previous function right here, over 2. So if you plug in some values, you can clearly see that this is what this function turns out to be. So now we must find our Fourier transform of this. So once again, let's draw our fancy f. And let's get our Fourier transform on. Alright, once again, using the wonderful power of Google, we find the Fourier transform looks something like this. 1/2 times the summation of, once again, -infinity to infinity, delta of omega minus 2 pi times k. K is our integer, of course, remember that. Plus, and I'm going to come down here and write this just so it's easier, 1/2 times the summation of -infinity to infinity of delta, and this part's going to look really similar to you, pi minus 2 pi k, which again, k is an integer. Remember that, it's very important, or at least that's all I'm told. So now that we have our p omega and our x omega, now all it's left to find is our xpn and then our xp omega. So to do that, let's analyze these two graphs. So we know that these are being multiplied together, and if you look at it, if you multiply this one times this one, you're going to get 0. Multiply this one times this one, you're going to get 1, and so on and so forth. And if you'll notice, our new function is going to look something like this. Let me draw out the axis here. It's going to look something like this. which, if you've been paying close attention, you'll notice is the exact same as this one, which basically means that our xp of n is this, which implies, therefore simple, that our xp of omega is going to be our p of omega. Pretty simple, pretty straightforward. Just taking a look at our graphs, putting them in their functions, just basically writing a function based off the graph, and then simply taking the Fourier transform of it. So there you have it. There's the answer to this problem. I hope you do well on your tests. And one more thing. Go Titans. Alright, thank you. Bye.